Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. Today's question is GCD reduction. In this question, we are given an array A of length n and we define its score after applying the operation n minus 2 times, and the operation is defined as follows. So we take the first three elements of the array. So let's say if the array is A1, A2, A3, A4, and so on. So we take the GCD of A1 and A3, and we also take the GCD of A2 and A3, and if the GCD of A1, comma A3 is less than or equal to the GCD of A2, comma A3, we remove the element A1 from the array. Otherwise, we remove the array A2, we remove the element A2 from the array. Now, after the deletion, the remaining elements are re-indexed to start from 1. So let's understand the score with an example. So let's say we are given the array as 4, 3, 1, 2. So in the first operation, we'll check the GCD of, okay, it is 4, 3, 2, 1. So in the first operation, we'll check the GCD of the elements of array of A1 and A3. And this is clearly equal to 2. And now the GCD of 3 and 2 is equal to 1. So we have the GCD of A1, comma A3 greater than the GCD of A2, comma A3, right? So we remove the element A2 from the array. So now we are left with 4, 2, and 1. In our next operation, we'll compare the GCD of 4, 1 and the GCD of 2, 1, which is 1 in both the cases. So because the GCD of 1, comma 3 is less than or equal to the GCD of A1, A2, comma A3, we'll remove the element A1 from the array. So now ultimately we are left with 2, 1. And in the end, after applying n minus 2 operations, we'll always be left with two elements, right? Now the score of the array is defined as the first element of the two elements which we are left with. So in our case, the score is equal to 2. Now, in the question, we're given three integers, n, x, and y, and we need to find any array A such that which satisfies all of these conditions, that are the array A contains n elements which are distinct and are in between 1 and n. Now, what does this basically means? It means that our A has to be a permutation of n integers, right? Also, we are given that A of n must be equal to x, that is, the last element of the array must be equal to x. The second last element of the array must be equal to y. There must be some set of elements before it, and the score of the whole array must not be equal to y. So it must not be equal to y. So we need to find and print any such array A if it exists. Otherwise, we need to print minus. So now let's understand the problem statement better by seeing a few sample inputs. So in the first input, we are given 2, 1, and 2. So the only possible array which we can get is going to be equal to, this is the element x, this is the element y. Now the second last element must be 2, and the last element must be x, that is 1. And because this is the only possible array we can get, we see that the score of the array is equal to 2, because this is the first element of the array which we'll get after doing all the operations. And this is clearly equal to y. So the answer is minus 1. That is, no such possible array A exists. Now let's see another sample input. So we have 6, 6, and 5. So the last element has to be equal to 6. The second last element has to be equal to 5. And in our answer, we are given 3, 1, 2, 4 as the first four elements. Now if we apply the set of operations, we see that in the first operation, the GCD of these two elements is 1. These two elements is also 1. So the first element will get removed because the GCD of 1, 3 is less than equal to the GCD of 2, 3. Now in the next operation, we have the GCD of this and this as 1. The GCD of these two is 2. Now again, clearly we can see that the GCD of 1, 3 is less than or equal to the GCD of 2, 3. So this 1 will get removed. Now in the next operation, we have GCD of like 2, comma 5 is 1. This 4, comma 5 is also 1. So again, because the GCD of 1, 3 is less than or equal to GCD of the elements 2, 3. This 2 will get removed. Now, in the next operation, the GCD of 1, 3 is 2 and GCD of 2, 3 is 1. And in this case, this 2 is greater than 1, so this 5 will get removed. And ultimately, the final elements will, which are left, would be 4 and 6. And the score of the array is going to be equal to 4, which is not equal to y, which was 5 in our input, right? So this final answer, that is the final score we have, is 4, which is not equal to y. Hence, it is a possible array A. That is the answer. In the third input, we have 4, 4, and 1. And in the solution, we have 3, 2, 1, 4. So the second last element is y, that is 1. The last element is x, that is 4. And now if we apply the set of operations, we'll be getting the GCD of this and this is 1. The GCD of 1 and 2 is also 1. So this element would be removed. In the next operation, this element would be removed and ultimately we'll be left with 2, comma 4. And the score is equal to 2, which is not equal to 1. Right. So hence this is also a valid case. So this is pretty much the whole problem and the sample input. Now let's move to the solution. So I have written down the condition. So if GCD of A1, comma A3 is less than or equal to the GCD of A2, comma A3, then A1 gets removed. Otherwise, A2 gets removed, right? And we are already given that the nth element is going to be equal to x, and the n minus 1th element is always going to be equal to y, right? Now this seems like a constructive problem, right? We need to construct the array. So let's try to construct the array from the last. That is like, we'll first of all figure out what would this element be, then the third last element would be, and the fourth last and the fifth last and so on, right? So for this element, let's call this element some element k. We know that the GCD of k comma x must be greater than the GCD of y comma x, right? Because if this condition is true, only then this y would be removed and our final score would be different from y, right? So let's find out any possible value of k from 1 to n, which is not a part of 1 x comma y, right? Like we'll figure out or we'll find out any possible value of k such that the GCD of k comma x is greater than GCD of y comma x and k is not equal to x or y, right? Now let's try to find out what are this n minus third element would be. So for this element, let's call it z for now. So we want the GCD of this z comma y to be less than or equal to the GCD of k comma y, right? We want this to be true so that this z gets removed and this k does not get removed, right? Because we have arranged some k so that our final score becomes equal to k, right? So we do not want this k to be removed, but instead we want this z to be removed. So what if we put z equal to 1, right? Because if this z is equal to 1, then this GCD of z comma y would be equal to 1, and 1 is always going to be less than or equal to the GCD of k comma y, right? So for now, let's put this value as 1, right? This is an n minus 2 element, yeah. Now what should our n minus 4th element be, right? So for this n minus 4th element, and it will be like a little more clear why we had put a 1 over here instead of some other number, like very soon, because this will have a like really nice property very soon. So yeah, what should our n minus 4 element should be? Let's call it k2 for now. And we want the GCD of k2 comma k to be less than or equal to GCD of 1 comma k, so that this k2 does not get removed, right? Like this k2 gets removed and this 1 does not get removed, right? Because if this 1 got removed, then it was like useless to put a 1 over here, right? So we want this k2 to be removed. And for k2 to be removed, we want k2 to be co-prime with k, right? Because GCD of 1 comma k is always going to be equal to 1, right? So we want this GCD of k2 comma k to be less than or equal to this GCD of 1 comma k, that is 1. So we this the only possible candidate, like the only possible value of this GCD can be 1, right? So we want k2 and k to be co-prime with each other, right? And this is pretty much all of it right now. With this property, we can put in any set of numbers in any sequence before this, and this will be a valid solution. Why? Let's try to put in some value z over here, right? Now, what is the GCD of this z and 1? That is 1, right? Now, what is the GCD of this k2 comma 1? This is also 1. And this condition will always be true, right? So, irrespective of what we have over here, all of these elements will always get removed. So, that is the reason we had put this one over here, right? Now, you'll be worried like, would we always have a K2 or not, right? So, it can be proven that for n greater than 6, we can always find a valid K2 that is co-prime with this K. Right now, I'm not going to explain you the proof for that, but to get an intuition, what you can try to do yourself is take n equal to 6 or n equal to 7 and keep this one fixed and try out all the possible combinations for this x and y and see if you can get, or maybe like for x, y, and k, and try to see if you can always get a valid k2 or not. So yeah, that exercise is for you. But yeah, for now, this is pretty much the whole solution. We can put any z or like all the rest no, leftover numbers in any order before this k2, and we can like find k2 k by using brute force, and this is pretty much it, right? Now over here, we have already like there are some edge cases. So the first edge case is that what if the number of elements are 3, right? We are calculating k, we are calculating k2, we are putting 1, and we also have y and x. For this approach to work, the minimum size of our array must be like greater than 6, right? So what if n is less than or equal to 6? So in that case, what we'll do is brute force, right? Why? Because what is 6 factorial? That is like I think almost 720, and we can just try brute force for all of these 720 possible permutations and just figure out if there exists a valid permutation or not, and if it exists just print that permutation, otherwise print -1. So that is we can easily handle. Now what if like we are placing a 1 over here, what if already some y or x is equal to 1, right? So let's handle those cases as well. So what if x is equal to 1? Now if x is equal to 1, then we would have like y and a 1 and some inputs over here, right? Some numbers over here. And here we can see that the GCD of y comma 1 is 1, right? So if we consider the second last element to be k, we want the GCD of k comma y to be less than or equal to 1 for k to be removed. But for y to be removed, we want this to be greater than 1, which is never possible, right? So the answer will always be -1. And now what if y is equal to -1? Last case, right? So we have something of this order, right? Now in this case, if we put some z over here, then this z will always get removed straight away, right? Because the GCD of z and 1 is 1, k and 1 is 1. So 1, 3, the GCD of 1 comma 3 is less than or equal to the GCD of 2 comma 3. So this z will always get removed. So all the elements before this will always get removed. So the only thing which we need to find out is the value of this k, and we are done, right? So just print this k1 and x in the end, and before that just print any set of numbers and we are good to go, right? So yeah, this is pretty much the whole solution. The time complexity would be like roughly n log n because we're calculating GCD, which is almost log n. And yeah, that's it. So now let's see the solution in C++ and Python. So yeah, this is the solution in C++. So we'll start by taking an input of n, x, and y for each test case. We'll do the brute force part first. So if n is less than or equal to 6, just define a permutation, fill it with a permutation that is 1, 2, 3, 4, 5, 6. Define that, okay, we are not done yet. And just run a loop for each permutation and check if is my current permutation a valid permutation or not. If it is valid, just print it and break, mark done as true. Otherwise, if it is not done, if you could not find any possible permutation, just print -1 as the answer. Now, this is our generic solution. So we'll start by finding k. We have defined the k as -1, and we're checking if the GCD of I comma x is greater than the GCD of y comma x. And this I is not equal to y and I is not equal to x. We have found some possible value of k, so we'll break from the loop. If we could not find any possible value of k, we'll print -1 and return. Now this is our edge case. So if y is equal to 1, we'll simply print k1 and x in the end, and we'll print the rest of the permutation in any order. So we'll print all the elements from 1 to n, and if they are not equal to y, k, and x. Similarly, now we are going to find k2 if y is not equal to 1. So we have defined again k2 as -1, and we're running a loop from 1 to n. Now if k2 is not equal to y, k, x, and 1, because those are already the 4 candidates we have used, and if the current candidate is co-prime with k, then we have found a possible candidate for k2. So we could also break after this statement, but yeah, it doesn't really matter that much. So we have found a possible candidate for k2. Now if k2 is equal to -1, will it return? But yeah, this statement is unnecessary. So even if we remove this statement, we'll still get an AC. Now in the end, we'll just print our permutation, and that's it. That's pretty much the whole solution. In C++, the time complexity is n log n because we're just running a few of and loops and calculating the GCD, which is log n. So the overall is n log n. Now let's see the solution in Python. So yeah, we are running this function solve for each test case. We're taking an input of n, x, and y. And we'll start by running the brute force. So if n is less than or equal to 6, we'll run a loop for each permutation possible of size 6. Then we'll check if the last element is equal to x, or the second last element is equal to y. If this is not true, then we'll continue because that has to be true in our permutation. Now, if that is true, we'll check the GCD condition and we'll get the score of the array. And if the score is not equal to y, we have found a possible permutation. So we'll print that permutation and we'll mark done as true. And if we could not find any permutation, we'll simply print -1 and return. Now, this is the constructive approach that we discussed. So we'll start by picking any value of k such that the GCD of k comma x is greater than the GCD of y comma x. And if we found any possible value, we'll mark it, and we'll break from the loop. And if we could not find any possible value, we'll simply print -1 and return. Now let's discuss the special edge case that was y is equal to 1. So in that case, all we need to do is print k1 and x in the end and just print the rest of the permutation in any order. So we'll just iterate from 1 to n, and if I is not in between x, y, and k, we'll print I and will return. And if y is not equal to 1, we'll find our candidate for k2. So we'll find a possible value I in range 1, n that does not belong to x, y, k, and 1 and is co-prime with k. Right. So if we have found any possible such value, we'll mark k2 as I. And if we could not find any such k2, we'll print -1. But yeah, this condition again is unnecessary because we'll always be able to find a k2 for n greater than 6. And in the end, we'll print our answer. So we'll print all the elements I if they do not belong to x, y, 1, k, and k2. And in the end, we'll print k2, 1, k, y, and x. So yeah, the overall time complexity for this solution would be n log n because calculating this GCD would be almost logarithmic, and we are just running some of and loops and calculating the GCD. So the worst case time complexity would be n log n. So yeah, that is for this video. I hope you liked it. Thanks. Bye bye.